The first topic that we are going to cover is a number system. Number system is a very important topic. Many questions will be asked from here, directly or indirectly. So let's start by discussing about some very basic topics. First one is a natural number represented by n. Here the number is greater than 0, which means 1, 2, 3 and so on. Next one is a whole number. Here the n is greater than or equal to 0. 0 and natural number included is whole number 0, 1, 2, 3 and so on. Next one is integers. Integers include negative integers, minus 3, minus 2 and so on. It includes positive integers and 0. 0 is neither positive nor negative integer. Next topic is even and odd number. You all know about it. N by 2, remainder is 0, then it is an even number, otherwise it is odd. Next one is a prime number. Prime number are the numbers which are divisible by 1 and themselves. So example would be 2, 3, 5, 7, 11 and so on. Here 5 is divisible by 1 and 5 only. Other numbers cannot divide it, so it's a prime number. Also all other numbers which are not prime is called a composite number. Remember that 1 is not a prime number. So we will start by discussing questions. Along with it we will discuss different topics as we move on. So let's go to the first question. Question number 1. Which of these is a prime number? So let's try to do this. Let's take 187, option A, 187. To test whether this is a prime number or not, first you need to find out the root of 187. Root of 187. Okay. Root of 169 is 13 and root of 196 is 14. So the number is somewhere between 13 and 14. So let's take it as 13.4 or 13.6, anything like that. Whatever the number is, round it off to the next integer. So even if it's 13.1, round it off to 14. Now list out all the prime numbers that are under 14. So it will be 2, 3, 5, 7, 11 and 13. Now to test whether 187 is a prime number or not, all you have to do is to check whether 187 is divisible by these numbers. So 187 is of course not divisible by 2. 187 divided by 3, it's not possible. There will be a remainder of 1. 187 divided by 5 is not possible. 187 divided by 7. 187 divided by 7. 2, 4, 7. Again not possible. Next one is 187 divided by 11. It will be 1, 7, 7, 7. Okay. So 17 is the answer when you divide 187 by 11. It is divisible by 11. That means it is not a 187 is not a prime number. So you might have two questions here. First one will be, why did we take only up to 14? Okay, all the numbers were less than 14. And second would be, why did we choose only prime numbers? To answer that, let's take another example. Okay, 32. 32 is obviously not a prime number, but let's represent this number as a two factors, like 1 into 32. Next one would be 2 into 16. Next should be 4 into 8. And that's it. If we go further, we will reach 8 into 4 and so on. So it's just the same. So if you observe here, the numbers here, the one side of the numbers are 1, 2 and 4. Square root of 32 is somewhere between 5 and 6. We round it off to 6. Now if you look at this half, you can see that all the numbers are less than 6. So whenever you represent a number like this, you will always observe that one side of the factor will always be less than root of the number. So there is no point in checking number above 6, because when we go above 6 we get 8 into 4, which is already covered here, so we don't have to go that far. I hope you understood the reason for the first one. Second one is why did we choose only prime? Here obviously 4 is not a prime number, but why did we choose only prime? We choose only prime because all these numbers can be represented in terms of prime factors. Suppose if we take 8, then 8 can be represented as 2 into 2 into 2, which is 2 raised to 3. So we can represent it as prime factors. So I hope you understood the two reasons why we took only less than 14 and why we took only prime numbers. You can apply the same for the rest of the question. Let's take 191. 191. We do the same. We find the root. The root is around 14. So numbers, prime numbers less than 14. Again the same list, 2, 3, 5, 7, 11 and 13. If we divide it with 2, not possible. 3 is not possible. 5 is not possible. 7 is 191 by 7. 5, 1 is not possible. 191 by 11. 8, 1 not possible again. 13 is 6, 1 remainder becomes 6, 1, it's not possible, and you can just try it on your own. So 191 is a prime number. I have given option E as more than 1, so you have to check C and D too. So if you check C, again the same procedure. If you observe closely, you can find that it is divisible by 3. So it's not a prime number. So we come to option D, 2, 5, 3. We look at 2, 3, 5, 7. It's not divisible by all those numbers. It is divisible by 11. So 2, 5, 3 by 11, 2, 3, 3, 3. So it is divisible by 11. So 2, 5, 3 is a not prime. So option B is the answer. It is quite a lot of work to do when we have to find whether the number is prime or not, because we have to divide it with each number. So in the case of 253, we have to divide by 2, 3, 5, 7 and 11. So larger the number, larger work should be done. Anyways, you have to understand divisibility rule because it will help you a lot when tackling questions like this as well as other questions. So let's look at divisibility rules. I will clear this out. You obviously know the number that ends by 0, 2, 4, 6, 8 is divisible by 2. A number is divisible by 3 if the sum of its digits is completely divisible by 3. An example would be 6, 4, 5, 7, 8. To check whether this number is divisible by 3 or not, all you have to do is add the numbers 6 plus 4, 10 plus 5, 15 plus 7, 22, 22 plus 8, 30. So 30 is divisible by 3. So this number is divisible by 3. Next one is divisibility by 4. A number is divisible by 4 if the number formed using its last two digits is completely divisible by 4. An example is, let's take 6, 4, 5, 7, 8 again. 7, 8 is not divisible. 7, 8 is not divisible by 4. So this number is not divisible by 4. So another example is 6, 4, 5, 8, 0. 80, the last two digits 80 is divisible by 4, so this number is divisible by 4. So for 2, you check whether the last digit is 0, 2, 4, 6, 8. And for 4, which is 2 raised to 2, you check whether the last two digits is divisible by this number. So I hope you saw the pattern. Now let's look at 2 raised to 3. 2 raised to 3 is 8. To check for the divisibility of 8, you have to take 3 digits, 580, and check whether this number is divisible by 8. If it is, the whole number is divisible by 8. So I hope you got the pattern. Next is divisibility by 5. Ending number is 0 or 5, then it is divisible by 5. A number is divisible by 6 if the number is divisible by both 2 and 3. So example would be 6, 4, 5, 7, 8. It is of course divisible by 2. Now we look whether it is divisible by 3 or not. The sum of digits is 30, so it is divisible by 3, and it's of course divisible by 2, so it is divisible by 6. Now for divisibility by 9, a number is divisible by 9 if the sum of its digits is completely divisible by 9. Example would be 6, 4, 5, 7, 5. When we add the digits 6 plus 4, 10, 15, 22, 27. So 27 is divisible by 9. So this number is divisible by 9. Next is divisibility by 10. The last digit is 0. Next one is divisibility by 11. A number is divisible by 11 if the difference of the sum of digits at odd places and sum of digits at even places is either 0 or is divisible by 11. In the last question, the option D was 2, 5, 3. When I was writing the options, I wanted to have one which was divisible by 11 only. So what I did was I added these two numbers, 2 plus 3, and I made sure that the middle number is equal to the other two. So 2 plus 3 is 5 and the middle number is 5. So what you basically do is 2, 5, 3, 1, 1. So this number is divisible by 11. 1 plus 2 plus 3 is 6. And 1 plus 5 is 6. So the sum of these alternate numbers should be equal to sum of the rest of the numbers. Or another possibility is 6, 0, 5, 4, 4. If you take the alternate numbers, it is 6 plus 5 plus 4 is 11, 15. Minus these two is 4. 4 is equal to 11. So either these numbers should be equal or should be 0. That is 1 plus 2 plus 3 is 6. Minus 6 is equal to 0, or the difference become equal to 11, or multiples of 11 can be 22 or 33 or anything like that. So this is the divisibility of 11. It is very important. I hope you understood that. I am only taking those numbers which are easier to remember. Otherwise too much information will not be useful for you. So I will give just one more, and the rest of the ones, if you want to know, you can check it out. Divisibility rule of 25 is the last two digits should be either 00, 25, 75 either of these numbers, then it will be divisible by 25. I hope you understood this much. Some of them, especially the basic ones like 3, 6 or 9 or 11 will be very useful when you do complex problems. It will help you save a lot of time. Go through this again if you didn't understand it properly. Now we move on to the next question, question number 2. 637 plus 478 whole square minus 637 minus 478 whole square all divided by 637 into 478. So obviously you cannot just add this number then find the square. It is too large and it will take a lot of time. It is not at all feasible. So before moving on to this question, let me give you some expansions. Most of this you will already be aware. A plus b the whole square is equal to a square plus b square plus 2ab. A minus b the whole square would be minus a square plus b square minus 2ab. Okay, next is a plus b into a minus b. This is very important. You should definitely know this. A square minus b square. Next is a plus b the whole cube is equal to a cube plus b cube plus 3ab into a plus b. Last one, a minus b the whole cube is equal to a cube minus b cube minus 3ab into a minus b. I will just add one more. A plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. I hope that you already know these equations. So this is nothing new for you all. So let's apply a couple of these equations here. Let's take a 637 as a. Okay, 637 as a and 478 as b. So now this equation changes to a plus b the whole square minus a minus b the whole square divided by a into b. Now let's expand it. A square plus b square plus 2ab minus a square plus b square minus 2ab. When you open the bracket, a square b square get cancelled, so it becomes 4ab by 2ab plus 2ab, 4ab by ab. AB gets cancelled, so answer is 4. So it becomes very simple when you apply the expansions. If you think these questions are very simple, don't worry, we will get into tougher questions later on. Next question, question number 3. On dividing a number by 342, 47 is a remainder. What will be the remainder if a same number is divided by 18? So let's take an example. Divide 32 by 5. Okay, when you divide 32 by 5, you get 6 minus 30, you get remainder as 2. So here we have the quotient which is 6, divisor 5 and remainder 2. So if you want to form our number 32 back, 32 can be represented as 6 into 5 plus 2. So 6 here is a quotient q into divisor plus remainder. So applying the same logic here on dividing a number by 342. So 342 is the divisor. 342 into quotient we don't know q plus remainder is 47. On dividing a number by 342, so the number is n, let it be n. So the number is 342q plus 47. What will be the remainder if same number is divided by 18? So same number 342q plus 47 is divided by 18. So we split it. It becomes 342q by 18 plus 47 divided by 18. So here if we divide this by this, we get 116, 2 is 9. So 19q, there is no remainder here. So whatever remainder we will get in the final answer will be formed from this half of the equation. So here 47, 18 is 2, it is 36, so we get the remainder of 11. So here the remainder is 0, here the remainder is 11. So option A is the answer here. Now we move on to question number 4. So before taking on this question, let's observe some things. 2 raised to 1 is equal to 2. 2 raised to 2 is equal to 4. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is 64. 2 raised to 7 is 128. 2 raised to 8 is 256. 2 raised to 9 is a 512 and go on and on. If you observe closely, you can see that there is a pattern. The unit digit is 2, 4, 8, 6. Again 2, 4, 8, 6. If you look at here, it will again have the same pattern 2, 4, 1, 0, 2, 4, 2048 and so on. And this is true for all the numbers. You can check other numbers and look whether my explanation matches. So whenever you increase the numbers power by 4, the unit digit remains the same. So here 3157 all raised to, let's write to 754 in terms of 4. 754 by 4 will be 1, 35 is 8, 34 is 8, and we get a remainder of 2. So we write here as a 4 into 188 into 3157 all raised to 2 to compensate the remainder. So what is the value of 7 raised to 4? Let's look at that. 7 raised to 1 is equal to 7, 7 raised to 2 is 49, 7 raised to 3 is 343. 7 raised to 4 will be, the unit digit will be 1, the rest of the things doesn't matter. Here 3157 all raised to 4, it becomes 1. So the unit digit here is 1 into 3157 raised to 2. 7 raised to 2, the unit digit is 9. So 9. So final answer becomes 1 into 9, which is 9 itself. Option B is the answer. I hope you understood the pattern, and this is how you solve these kinds of questions. Question number 5. What will be unit digit in so it's a big number, you cannot basically multiply all of them. So how will you find a unit digit in this kind of scenario? All you have to do is multiply all the numbers in the units digits place. So that means 8 into 9 into 6 into 2. So 8 into 9 is 72 into 6 into 2. 72 into 12. 72 into 12 will be 720 plus 144 is 864. So the unit digit is 4. So option C is the answer. We can actually simplify the process again. So let's take this step, 72 into 12. Here instead of multiplying 72 into 12, all you can do is take the unit digit again. 2 into 2. 2 into 2. 4. So you could have applied it here, or you could have applied it here. 2 into 6 into 2. So it will all give you the same answer. Now we come to question number 6. 3 raised to 57, 6 raised to 41, 7 raised to 63. So this is an application of question number 4 and 5 together. 3 raised to 57 can be written as 3 raised to 4 into 14 into 3. Now 6 raised to 41 can be written as 6 raised to 4 the whole raised to 10 into 6 into 7 raised to 63 can be written as 7 raised to 4 the whole raised to 15. So it only becomes 60 here. So we need into 7 raised to 3. So unit digit in this part will be 3 raised to 4. 3 raised to 1 is 3, 3 raised to 2 is 9, 3 raised to 3 is 27, 3 raised to 4, 81. So here the unit digit is 1, so 1 raised to 14, 1 into 3, 3. Here it will be 6 raised to 4, 6, 36, 216. So wherever you go, you will get it as 6. So again we get 6 here, and when we multiply it with another 6, we get 6. We reach the last number, which is 7 raised to 4. 7 raised to 4 would be 7, 49, 3, 4, 3, 1. Okay. So unit digit here is 1 again. So 1 into 7 raised to 3 is 343. The unit digit is 3. So it becomes 3 into 6 into 3 into 6 into 3. 3 into 6, 18. 18 into 3 is 54. So unit digit is 4. Option C is the answer. Now we come to question number 7. Root of 72 plus root of 72 plus root of 72. It goes on to infinity. So whenever there is a repeating pattern of numbers like this, the first thing that should come to your mind is to equate this to x. X is equal to root of 72 plus root of 72 plus root of 72 and so on up to infinity. So instead of writing this, we can write it as 72 plus x. X is equal to root of 72 plus x. Now I want to avoid the root, so I square both sides. It becomes x square is equal to 72 plus x. So now we get a quadratic equation, x square minus x minus 72 is equal to 0. Now let's solve it. X square minus 9x plus 8x minus 72 is equal to 0. 8 into 9 is minus 72, is right. So we take x as common, x minus 9. We take 8 as common, x minus 9 is equal to 0. X minus 9 into x plus 8 equal to 0. So x is either equal to 9 or minus 8. The option here is C, 9. Now we come to question number 8. What is the remainder when was divided by 25? Okay, this is a simple question. If you look at this number, the last 2 digits is 0, 0, which means it is divisible by 25, completely divisible by 25. So remainder here is 0. Again the same case here, remainder again is 0. So the answer is option A, 0. I hope that you understood these questions. If not, see this again. And before moving on to the next lecture, make sure that you do these questions on your own. Stay safe and see you again.